Hey everyone, my name is Sahil and in today's video we'll be discussing down conductors. After this video, you will have a clear picture on how to select a down conductor for your lightning protection system and the natural components that form a part of the lightning protection system. So let's start by understanding the basics. What is a down conductor? The down conductor is the electrically conductive connection between the air termination system and the earth termination system. Its primary purpose is to safely transport intercepted lightning currents to the ground without causing any harmful temperature spikes. So let's understand, how do you select a down conductor? Firstly, the size of the structure. The size and configuration of the structure determine the scale and complexity of the lightning protection system. If the size isn't considered, the down conductor system might not be adequate to handle a lightning strike, potentially causing structural damage or risking people within the structure. The perimeter and external edges of the roof are also vital. They help protect the ground surface. Number 2, material and size. The material and size of the down conductor directly impact its conductivity and ability to handle the lightning current. Choosing the wrong size or material could lead to overheating or failure of the down conductor during a lightning event. For example, material like stainless steel or aluminium can have less current carrying capacity, or a conductor that's too small might just not be able to handle the current, causing it to overheat, potentially leading to a fire. Either of these issues can risk the structure and its occupants. Number 3, positioning. The distribution of down conductors around the perimeter of the structure, starting at the corners, ensures an efficient pathway for the lightning current to the ground. Poor positioning could lead to inefficient current discharge, possibly causing overheating and damage to the structure or even a fire. Number 4, structural elements. If the presence of structural elements like gates, precast components, or metal installations is not taken into account, the efficiency of the down conductor system could be compromised. These elements might interfere with the direct path of the down conductor, leading to inefficient grounding and increased risk of structural damage. Number 5, lightning protection system class. Each class of lightning protection system has different requirements, and not adhering to these requirements could result in an inadequate protection system. Using the IEC 62305 Part 3 standard to guide the selection ensures the system will perform effectively under the specific conditions associated with each class. Number 6, temperature rise. If the down conductor cannot handle the maximum temperature rise delta T for the class of lightning protection system, it could fail or become damaged during a lightning event. This could compromise the entire lightning protection system, making the structure vulnerable to lightning damage. Selecting a down conductor is a complex task. While selecting one, please refer to the IEC 62305 Part 3 standard, the lightning protection design standard, or get on a call with one of our engineers. Details will be in the description. Now let's discuss the natural components of a down conductor. These are integral parts of the building structure which, due to their conductive properties, can serve as part of the down conductor system and help in lightning protection. Using these components effectively can reduce the number of separately installed down conductors in your structure. Let's break down what could be considered as natural components. Metal installations. These could be large interconnected metal structures within the building, such as steel beams or reinforcements. They can serve as a down conductor provided their connections are permanent and that they meet the minimum requirements like size, current carrying capacity, and conductivity for down conductors. However, there are some exceptions to this. Pipes or conduits carrying flammable or explosive materials cannot be used as down conductors. The reason is simply that this equipment might have non-metallic seals or joints which won't be electrically conductive and could pose a risk during lightning strikes. Metal skeleton. If the structure of the building includes an interconnected metal frame, such as a steel skeleton or reinforced steel, this could serve as a down conductor system. In such cases, additional ring conductors might not be necessary, as the metal frame would already facilitate the splitting of the current. Precast components. In buildings that incorporate precast components, the terminal connectors for the reinforcement within these components can serve as natural down conductors, provided they maintain an electrically conductive connection. facade elements and metal substructures. If the dimensions meet the requirements for down conductor systems, facade elements, mounting channels, and the metal substructures of facades can also serve as natural down conductors. They must be securely interconnected and have a safe current carrying connection to both the air termination and the earth termination systems. I hope you now have more clarity on down conductors, their selection procedure, and the natural components. At Axis, we have a team of 40 plus engineers who are here to help you in designing, installing, and testing your lightning protection and grounding systems. Our products have been used in substations, data centers, factories, and even in everyday residential and commercial buildings. If you like this video, please like and subscribe to our channel for more videos about lightning protection, grounding systems, along with other videos about electrical engineering. I'll see you in the next video.